So basically what I'm going to talk about is I'm going to look at certain of the great innovations or advances in the history of life, such as photosynthesis, high acuity vision, terrestrial life, oxidative metabolism, and endothermy. These are some of the basic innovations that occurred in the history of life. And I'm going to argue that whatever the proximate causes were, the immediate causes of these innovations, they could only occur if there was a preceding prior fitness in nature which allowed their actualization. So basically, in the case of photosynthesis, terrestrial life and things, there has to be a vast set of preconditions in nature. Nature must be exactly right for these innovations to occur. However the actual proximate causes were of the innovations, nature has to be fit for these innovations to occur. This next slide is baking a cake. It's like baking a cake. I've never baked a cake, by the way, so you know. But I've seen people do this. They do this sort of thing, and they have a recipe. But if you bake a cake, you also have to have, as it were, preconditions. You have to have the right ingredients before you bake the cake. And that's really the essence of this talk is extraordinarily simple. It's just an inventory of the extraordinary nature of these conditions before you can get advance one, innovation two. So that's so it's like baking a cake. You need the right ingredients before you can make a particular cake. So let's start with the prior fitness of nature for the transition from water to land. There's endless discussion of how life left the oceans and went onto the land, how the first plants came out to sea, how the first invertebrates came out to sea, and how the vertebrates came out to sea. But there's one thing's for sure: they could never have left the sea for the terrestrial realm if the terrestrial realm wasn't profoundly fit already for the becoming of terrestrial life. And what do I mean by that? Well, there could be no life on the land without the hydrological cycle, which delivers water to the land. And there's something very beautiful about this cycle. How does the water get onto the land? The water delivers itself by its own unique properties to the land, and that it exists in three material states: gaseous, liquid, and a solid. And it's the only substance on the surface of the planet which exists in these three particular states in the ambient conditions on the Earth. So water delivers itself to the land by its own properties. But water itself is not enough for life. You need water, and you need all the minerals that's necessary for life. Well, amazingly again, water's mobility as a liquid and as a solid is wonderfully fit for the erosion of the rocks. So now we've got water delivering itself to the land, and we find that the very fluid that goes onto the land is now fit for eroding the rocks. And its power as a solvent is fit for leaching the essential minerals from the rocks. So water delivers itself to the land, and there's beautiful parsimony in all this. The same compound now leaches the chemicals that are needed for life. It gives itself, and it leaches the chemicals from the rocks itself for terrestrial life. So water's erosion and weathering of the rocks provides essential minerals for life. All these minerals are leached from the rocks for the terrestrial life. And when you look at the properties of water, you find not only is it able to deliver itself to the land, but it's uniquely fit in multiple ways for eroding and weathering the rocks. The surface tension draws the water into the cracks in the rocks. It then expands and fractures the rocks. It's an excellent solvent. It's the ideal solvent. It aids the leaching of the essential minerals from the rocks and their distribution throughout the terrestrial hydrosphere. It forms with carbon dioxide and acid, which further weathers the rocks. The low viscosity of water creates rapid running streams and rivers, which promotes erosion. And of course, the low viscosity of ice as a solid aids erosion of mountains via glacial action. So we've got a whole ensemble now of elements of fitness with wonderful parsimony, all condensed into this one fluid to give us terrestrial life. And take away almost any of these characteristics, and those fisherpods would never have left the sea. There'd be no terrestrial life on land without this fitness already present in nature. Now, another outcome of the erosion of the rocks by water is the formation of the soils with the micropores which retain water. So not only does water get itself to the land, erodes the rocks, it provides the soils which are essential for the growth of plants and trees on the land as well. So the whole thing flows from the properties of water. And you can arrange these properties in a sort of elegant hierarchy of phenomena. The water goes onto the land, it leaches the minerals, gives nutrition to the things on the land, it forms the soils for the plants. So in other words, life on the land depends then on a fantastic suite or ensemble of fitnesses in water. If they didn't exist in nature, we wouldn't be sitting here now, and life would never have left the seas at any scale at all. Okay. So now we are large macroscopic aerobic endotherms. Okay. So how do you have endothermy? What do you need for endothermy? Well, you actually need the thermal properties of water. So for endothermic organisms on the land, well, water's provided the nutrients, it's provided the trees, it's provided the water itself. Endothermy allows an organism to function at the same temperature regardless of environmental temperature. It gives faster nerve conduction, reflexes, and more powerful muscles. Well, wow, isn't that convenient? Endothermy is a great advantage to biological systems. And surprisingly, water has one of the highest specific heats of any common fluid, and indeed of many other substances. And what's that? The significance of that is, of course, it buffers any organism maintaining its temperature at a constant level. The high specific heat of water helps the buffering process hugely. And if you go back to 1913 and you read Henderson's Fitness of the Environment, he said that an adult human produces a great deal of heat. If the heat capacity of the body corresponded to that of most substances, the same quantity of heat would be sufficient to raise his body temperature between 100 and 150 degrees. That just shows you the fitness of the specific heat of water for endothermy. But there's another thing as well. When the temperature reaches, say, body temperature, 37, 38 degrees, or goes higher, the only way you can lose heat is through the evaporative cooling of water. And once again, now water has the highest evaporative cooling of any known molecular substance, which is incredible. So water is already fit for endothermy. Without these properties of water, there'd be no endothermy. Without the properties of water, there'd be no water on the land. Without the properties of water, there'd be no nutrients on the land. And without the thermal properties of water, there'd be no endothermic organisms like ourselves. No matter how much, even God can't do it. Because God himself would need, like the ingredients in building a cake, you've got to have the ingredients in nature. And then again, Henderson comments, at body temperature above, there can be no loss of heat at all by conduction and radiation, and the whole burden is therefore thrown upon evaporation. But there's a nice and beautiful twist to this as well. How does the heat get to the skin? It's carried by water in the circulation. So water even takes the heat. And then when it gets to the skin, the high evaporative cooling of water takes the heat out of the body. So that in fact, this is all elements of fitness for not just the life on the land, but specifically now for endothermic life on the land like ourselves. None of this could possibly happen if it wasn't for this prior fitness in nature. Okay. So that's one example. So no endothermy without the prior thermal properties of water. Okay, so what about this? This is I think far more remarkable than the hydrological cycle is a simple beginning to this. Now let's look at the prior fitness of nature for photosynthesis. All advanced organisms on Earth depend on oxidative metabolism to generate metabolic energy. So let's think about this. Oops. Now the visual spectrum within the vast range of electromagnetic spectrums on Earth, it occupies a tiny fraction of the electromagnetic spectrum. And in fact, normally, I'll just do this, I think. Normally, it's portrayed like that. But actually, it's virtually one line, an infinitesimal line in a vast range of different electromagnetic radiations, okay? Radiations. So, but there's something what do stars give off? Well, they give off visual light, and they give off infrared. And so stars, and the sun is a typical star, but it's slightly warmer than most stars. Its temperature, surface temperature is about 6,000 degrees, and at that temperature, stars give off mainly visual light and infrared and heat, which is just what you need for life and just what you need for photosynthesis. So the radiant output of the sun is concentrated almost entirely in the visual and near infrared. And once again, this is the real situation. It's like one tiny line of radiation in the vast spectrum, in the vast range of the spectrum itself. So the cosmos is in fact flooded with, as it were, the light of life. You look at the stars at night, they're all giving off light, visual light, which has just the right energy levels for photochemistry. I think I missed that point back there. Yeah, sorry. I missed that slide, jumped it. The visual region has just the right energy for photochemistry. Sorry, so I missed that actually. So the sun gives out just the energy you need for photochemistry. And not just the sun, the entire cosmos is flooded with this light. It's the light for life. And as I said before, that's the case. So how does it get through the atmosphere? Now the plot's beginning to thicken. Well, it obviously does get through the atmosphere, because I can see the sunlight out there. If you look at the absorption spectrum of the atmospheric gases, you find that, in fact, all the radiation, all the high energy radiation sort of south of the visual region is, in fact, absorbed by the atmosphere. But wow, isn't that good? The visual light, which you need for photochemistry and photosynthesis, comes right down to the surface of the ground. And what happens in the infrared? Well, that's just what you want too, because here you have some absorption bands. You need to absorb some of that heat, because that raises the Earth's temperature to about 33 degrees centigrade and maintains the Earth at a clement average 15 degrees centigrade over the surface of the Earth. So in fact, the absorption spectrum, this is the microwave region, and this is the radio window. So this is a fascinating bit of fitness in nature for photosynthesis. And I'm going to say something else about that shortly in the next few slides. I hope I'm not going too fast. I sometimes rattle along too quickly. And sorry. So the electromagnetic radiation which penetrates the atmosphere is in this same tiny part of the electromagnetic spectrum. So the radiation of utility for life is in the visual and near IR, and that's exactly the stuff that the atmosphere lets through. So the sun shines the light, the radiation you need, emits the radiation you need, and the atmosphere lets just that radiation through into the Earth and manipulates it for the purposes of life. Well, obviously, water also has the same window which allows through visual radiation. In fact, visual radiation penetrates water to about, I think, nearly 500 meters. So photosynthesis can occur in the depths of the ocean, or certainly in the oceanic waters. So that's just repeating that again, that the electromagnetic radiation which penetrates water is concentrated in the same band, the visual and infrared. Now look at this, it's very interesting. I found this absolutely fascinating, I have to say. I'm repeating this again. Just imagine if these things had been reversed. If in fact the visual light was actually absorbed, and in fact the infrared, if the visual was absorbed, and this was, you rearrange this slightly, you could have a runaway greenhouse and all sorts of deleterious effects. But this relationship between visual transmission and the absorption of the IR is absolutely critical to life on Earth. And I can say for sure that, in fact, basically as far as photosynthesis is concerned, without these facts on the surface of the planet, there would be no photosynthesis, probably no life. Another beautiful bit of teleology here is the ozone story. Ozone protects us from dangerous UV in this region of the electromagnetic spectrum. So how do we get ozone? Well, it's a really beautiful thing. Oxygen gives us ozone. Ozone's sort of the daughter of oxygen. And so by protecting plants from damaging UV, ozone promotes photosynthesis and consequently oxygen production. So oxygen, so to speak, promotes its own synthesis. And I found that, once again, a beautiful bit of teleology in nature, that actually is the case. So oxygen sort of promoting its own synthesis by protecting photosynthetic apparatus from damaging UV radiation. So there's more teleological twists the further you look into this situation. This is the basic, everybody knows this is the basic sort of chemical of photosynthesis. But there's a fantastic catch here. The gases which are letting through the light aren't just peripheral players in the process. They are the major reactants. In other words, it is the three major reactants, CO2, H2O, and O, which ensure by their collective absorbent properties in the atmosphere the availability of the vital light energy necessary to drive the reaction to completion. It's as if these gases were colluding intelligently to promote their own incorporation into the substance of living matter. So it's absolutely beautiful. So the chemicals with the right chemistry for photosynthesis have the right physical absorption properties to allow the process to occur. So we see wheels and wheels of teleology woven into each other. It's, so, I don't know. So what we can see as far as photosynthesis is concerned is an incredible series of extraordinary coincidences. And first of all, there's the radiation of utility life is concentrated in the visual in UV, in the visual in IR. The radiation output of the sun and most stars is also concentrated in the same region. Electromagnetic radiation which penetrates the atmosphere is concentrated in the same region. The electromagnetic radiation which penetrates water is also concentrated in the same region. If it wasn't for these coincidences, we wouldn't be sitting here, we wouldn't be oxygen-utilizing organisms, and we wouldn't be endothermic because of the other things I've already mentioned, right? So you can see now that, in fact, the basic innovations in the history of life on Earth depend on a fantastic prior fitness for those innovations to be actualized. It also suggests, of course, that the actual innovations themselves were also sort of designed for them to be actualized. So that's something I'm dealing with the prior fitness here. But I think it suggests that as well. So the Encyclopedia Britannica, commenting on this, says, considering the importance of visual sunlight for all aspects of terrestrial life, one cannot help being awed by the dramatically narrow window in atmospheric absorption and in the absorption spectrum of water. I love this quote from Sagan. I'd like to read it, actually. I think Sagan was a great poet. Whatever else he was a wonderful poet. Think of the sun's heat on your upturned face on a cloudless summer's day. Think how dangerous it is to gaze at the sun directly. What would we feel on its seething self-luminous surface or immersed in its heart of a nuclear fire? The sun warms us and feeds us. It permits us to see. And we'll talk about vision in a minute. It fecunded the earth. It is powerful beyond human experience. Birds greet the sunrise with an audible ecstasy. Even some one-celled organisms know to swim to the light. Our ancestors worshipped the sun, and they were far from foolish. It's a beautiful quote. It could be substituted for my talk, I think, actually. So there's another thing we have. We have eyes. We have high visual acuity eyes. And this is another twist to this teleological tale now, which I only discovered about a year ago when I was doing a monograph for the Discovery Institute. This is, of course, a cut through of the human eye. Okay. Now this is complex. Okay, very complex. But first of all, to have vision, you need to form an image. And images are formed because of the wave nature of light. You also have to detect energy. You have to detect it, and the photodetectors in the back of the eye detect particles of photons. So interestingly enough, vision depends on quantum weirdness. That light can make an image as well as being detected as a particle in the photoreceptor, which is a very nice idea. So I think without quantum weirdness, I'm not sure how I could arrange an eye. Anyway, vision depends on it. So this, just briefly to remind, this is my field, vision. So This is something from Descartes' dioptra. This is the image formation. And this is the photoreceptor in the back of the eye, which detects individual photons. Yes, individual photons, amazing as it is. An individual photoreceptor can respond to one single photon of light. So, oops. So anyway, now let's think about this again. So basically, I said earlier that in fact, and there's a slide I jumped over by mistake, that visual light has the right energy levels to activate matter for chemical reaction. And of course, therefore, has the right energy levels to be detected in the photoreceptors. Has the right energy level for activating chemistry for life and to be detected. So in the visual region generates electromagnetic radiation with the right energy for photochemistry and photodetection in the eye. Oops, sorry. Now, just a brief reminder of the phenomena of waves and diffraction, which occurs in light and occurs in water and so forth. The smaller, and you must have seen this at the coast yourself when you've spent time at the coast. The smaller the waves, the less they diffract. The larger the entrance, the less they diffract. So the degree of diffraction is directly proportional to lambda wavelength and inversely proportional to aperture. Now, diffraction limits visual acuity. And this is just a picture of what happens. For every point of light in the objective field you have on the retina, you have what is called an airy disk. It's not a perfect point. It's spread out a little bit. Okay? This is because of the phenomenon of diffraction. And the airy disk diameter, which is equivalent to the resolution of the eye, is proportional directly to wavelength and indirectly to aperture. So let's think about what this implies. So let's say the degree of diffraction is proportional to the wavelength of light. Now in the visual region, if the wavelength of light was slightly less, you would have a smaller airy disk. But you can't construct detectors based on biological principles much smaller than the photodetectors in the eye. They're only a few microns across, so you can't make them any smaller. So in fact, if the wavelength of light was actually, if the wavelength of light with the right energy for detection was actually slightly less, then in fact no increased resolution could be gained, because in fact the airy disk would be smaller, and it would be smaller than the diameter of a photodetector. So what happens if it was bigger? Well, if it was bigger and you wanted to recover, if it was bigger, the airy disk would be bigger and you'd lose resolution. Okay? So the only way you could recover resolution and reduce, as it were, the relative size of the airy disk would be by increasing the aperture. If you increase the aperture, if the wavelength length was 10 times more than it is, 5 minutes, I'll be done. Perfect, okay. If the wavelength of light was 10 times more, you'd have to have an eye the size of the head to have the same resolution. If it was 100 times, now remember we're talking about a spread of values of 10 to the 25, 20 to the 26. If it was 100 times bigger, you need an eye the size of a radio telescope to have the same resolution, right? So this is a very fascinating now coincidence in nature beginning to arise. And it looks as if, in addition to all the coincidences which allow photosynthesis, there's now another one which allows an eye of roughly the size commensurate with our biology to fit on our head, actually. So as I say, I only found this out a short time ago, and it blew me away when I realized that the wavelength of light was also fit for our being. So the wavelength of light is fit for high acuity vision in an eye of a size commensurate with biological organisms on our side. And now, beautifully, we can add another one of these extraordinary coincidences. So we've got the right area, the right part of the electromagnetic spectrum for photo detection. We've got the right stuff coming out of the sun, the right stuff going through the atmosphere, and so forth. And it's right for vision in a being of roughly our size, which is an extraordinary thing. So nature is fine-tuned. No, I've got 3 minutes now left. Okay, now let's just look, and this is just listing things. The prior fitness in nature for oxidative metabolism in air-breathing terrestrial organisms. The relatively low reactivity of oxygen, its reluctance to act in ambient temperatures, prevents spontaneous combustion. The existence of a fire retardant is necessary to stop the spread of fire. The low density and viscosity of air enables the work of breathing. The properties of the transitional metals, copper and iron particularly, allow the control, handling and activation of oxygen. Remember, it's the transitional metals which donate individual electrons, which activate oxygen to start the reduction of oxygen to water in the cytochrome oxidase, and of course allow hemoglobin to carry it in the blood, right? So without the transitional metals, you couldn't have oxidative metabolism. You can forget about it. It's impossible. You can't handle oxygen. They're the only atoms in the periodic table which will do this. The gaseous nature of CO2 enables excretion in the lungs, so you take the oxygen in from the atmosphere and you breathe it out in the same way. Now, I could this list goes on a lot longer than that. It's a very brief sort of summary. Okay, where do I go to? Okay, sorry, I'll go back again and then I'm concluding slide. Yes, that's it, yeah. So, I don't know of any evidence for design, and this is universal design. These are the laws of nature which extend right across the cosmos, okay? So I know of no evidence for design more extraordinary than this. I could go through 100 cases of these innovations in evolution and show you that each one depends on an incredible fitness in nature for its actualization. So you've got 4, and I've simplified everything I've talked about here. I could have greatly expanded on all these points, okay? So the Darwinian mantra that all you need for the account of the history of life, natural selection, is self-evidently wrong. Because whether you're God creating life or whether you're Darwin creating it, you need this fitness. And without these blueprints already built into nature, you can't move. Okay, so that's obviously wrong. And the final thought is this: if the necessary prior fitness or the blueprints built into nature, surely the actualization of these innovations is also built in. And last night I realized something I hadn't realized before, which you always get this when you're doing these things. I realized that what Steve Meyer and Gunter have been saying about the input of information to get these innovations, the proximate cause of these innovations, is sort of supported by what is now independent evidence of that. So this is independent evidence that the innovations themselves were also there by design in the most general sense. And I don't know why, I'd never actually seen that so clearly, but it's absolutely, it's overwhelming me now, yes. Gunter's gaps and Steve's input of information is borne out entirely by this evidence. And it's independent evidence. It's evidence of a preceding fitness, which suggests very strongly that those jumps, those innovations were also the result of some form of design in nature, whether it was an intervention or whatever. But it looks as if it would be designed as well. Okay, exactly 30 minutes, Gunter. I promise you.